I'd say go live. I'm gonna have to grab my phone because I don't have my setup to where I can read chat and all that. I have to read it off my phone. My videos. There we go. I don't want any of that. I just want the chat. I don't want really the video, if you know what I mean. So, I think this stream is up. I don't know if it is or not. I think it is. Hopefully it is. I should probably put this like somewhere else. It should be good. Alright, hey guys, welcome to the stream. I'm not where I usually am to actually stream this. But I'm gonna stream anyways, so let's just get that down. I think we're good there. We got our streaming stuff. Yeah, so as the title says, probably should do this like in a different one. We can do it in, let's see, I would say, what's a good place? Java's pretty cool, I guess. So we can actually do it in Java. So, yeah, I guess we could do it in Java. So, yeah. Anyways, welcome to the stream. If you are just coming in because you got the notification, I am currently I'm about to be starting up my Gameboy emulator, but I'm going to talk about it first. I'm not really going to just say I'm making a Gameboy emulator and watch me do it. I'm actually going to explain what I'm going to be doing and how I'm going to be doing it, and then going along with it because I have made emulators for things like this, and so let's do this one right there. So yeah, hey Bike Smith, what is up? Joining the stream, I see. Yeah, so I'm gonna be making a Game Boy emulator in Java, or at least I'm not gonna be making the graphics just yet. I don't think I can do the graphics just yet. I can only do at most the CPU and the RAM, and the CPU is going to be pretty neat. So yeah, I'm gonna actually get a little document sheet up. Oh, what's up? What is this? This is my coding challenges that I did for a competition. So yeah, I think that's one of my old emulators. So here's all this. This is what my old workspace looked like, and it's away from all my new projects. Nice, yes indeed, nice indeed. I don't allow access. I guess it's because it's a new Wi-Fi and it's not really because of. So allow access. So yeah, I gotta get this all correct. I'm gonna actually just create a new project. So I'm going to just call this Game Boy. Game. That's not, I guess, a game. Game is good, I guess. I mean, I accidentally pressed the enter button too quickly. It's eating up my RAM, both live streaming and going and doing Java, because Java's not best if you wanna live stream with. I would say the best to do that with is something that doesn't actively take up a lot of RAM. So like a text like JavaScript doesn't take up a lot of RAM. Or at least typing it, because it's not really an IDE, or Visual Studio Code doesn't take up a lot of RAM. But like an IDE like Visual Studio, or of course Eclipse, does take up a lot of RAM, and that takes up a lot of live streaming stuff. So I'm actually going to get an overview done on MS Paint. I can actually probably do them or just paint.net. Because that's like it's like basically Photoshop, but not Photoshop. It's Photoshop for people who want, it's free Photoshop for people who don't want to pay for Photoshop. It's really similar to it. It doesn't have all the aspects because it doesn't have all the power that Photoshop has. But it can get the job done. It can do a lot more things than MS Paint can, and it can do a lot of things that Photoshop can, but it can't do all of it. Yeah, Visual Studio is slow. I know. So hopefully we can get this down. So I'm just gonna draw a little rectangle right here. Man, what a Game Boy! All right, so this is the Game Boy. If you haven't heard of the Game Boy, well, you haven't really been alive. I could probably just use the rectangle tool. Shapes, rectangle. Okay, here we go. So it has random stuff. I don't care. So here's the Game Boy. I'll describe it for you if you haven't heard of it, which is a shocker if you haven't. It's not wanted. So basically, what the Game Boy is it's a handheld console. Open up Paint, Vietnam flashbacks. So I'm just gonna draw a little Game Boy right here. Yeah, they came out with Paint 3D, or Microsoft did, and I would say it's not as intuitive as Paint, MS Paint, or whatever you like to call it, but it actually has all the capabilities of newer software. So, and then there's some start buttons, like right here. How would I represent that? I don't know how I'd represent the start button and select button. Good enough, I guess. Man, that sucks. These just look like pills. Alright, so we can just do the next best thing. Images. No. Why is that $250? That's stupid. Like, I know they're like the new, I know like they're really expensive. Because for like if you want brand new and all that. So there we go. So here's the Game Boy. It was released in 1989. It was made by obviously Nintendo, and I'll go over what aspects it has. I could probably just pull like a memory map and grab that, but shut up, Eclipse. So the Game Boy, it was pretty popular back in the 80s and 90s, and I would say that it still lives on with the DS and the 3DS, but that line is kind of canceled, or it's about to be. They're not. My PC is worth $250. Are you kidding me? You're saying that your PC is like a Game Boy? Well, yeah, it's kind of too much for a Game Boy. Even like right beside it, you can get the Game Boy and Tetris for $30, which is a pretty sweet deal. So let's go over the aspects of the Game Boy. There is a video on this, like the autopsy of a Game Boy, and although I say it's really good, I'm not going to show it because I'd rather explain it myself and all that. So I'm actually going to Game Boy Eternals. Let's open that up. That's not a Game Boy, that's a Game Boy freaking Advance. Which one's a good one? I'd say this is a pretty good one to do. Is it clear? It's loading. It's good enough. So boom, copy and paste it there. Alright, so we got the internals right here. I'm just gonna escape. So we have the internals right here. I'll go through each part and I'll try to explain what each part does. So the first thing we have is, oh wait, it's not even showing any of these chips. Hold on. Game Boy chips, chip internals. That's not, these are cartridges. Game Boy chips. I'm trying to figure it out. Oh, it's not really. I would say this is pretty good. Game Boy Color. Nah, I want a Game Boy. Game Boy chip. Game Boy chips. This sucks because I can't get a good picture of the internals. My Game Boy still being sold. They're not being sold. Maybe the Game Boy Wikipedia page has the picture I seek. Nope. Reception. I guess we could just talk about it. I'm trying to. There's not really much I have to freaking describe. Alright, so welcome to the Game Boy. I can go to the autopsy and I can try to like get pictures there, but I'm not. So I'm going to actually try to explain what is. Please upload a stream on your channel. I want to watch it, but I don't have time right now. Do not worry. All my streams will be up on the YouTube channel. I think the past couple ones, which is the ones where I made a game, and I don't know what else I did on that live stream. I think I was working on like another tutorial on that live stream, but anyways, yeah, every stream is going to be uploaded to the YouTube channel, so you can watch it. So it won't be live obviously because it's a recording, but I'm just gonna talk about what a Game Boy is. So the CPU is a custom chip. Well, it's not really custom, it's just some features were removed, such like the NES with the 6502, and some features were added. So the CPU is basically an Intel, basically a stripped down Z80. So it has the registers, the registers of the Intel 8080, but it has the instructions of the Z80, which is just a later on model of the 8080. Or sort of like I don't know. Anyway, bye Mike Smith. I'll probably get at least the basics done today, like get all the classes laid out and all that. So yeah, we have a CPU, and it's basically, we have the Z80. It's basically a Z80, but not as complex. And then it has some input and output, due to it being a game console, you need a bit more than just a CPU. We have the RAM, which can be 8 kilobytes, and that can be extended using the cartridge RAM chips. The video RAM is 8 kilobytes as well, so you can't really do much with it. You can't really do much with the screen because it only has 4 colors, 4 shades of gray, which goes from black to white, and in the newer model it is dark green to lime green, which is not really good. So yes, and so now we have 2 pulse wave generators. I think the sound's going to be really complicated. especially for like Java, because you have to get all these. You have to get a lot of libraries for Java. And you have to get graphics. You have to get input and output. You basically, I think, lightweight Java game library can do that. I wouldn't like. We have to have a lot of code just to get something to display, but it'd be really, really fast and really good. And then the ROM, we have a 256 byte bootstrap, which is what I hope to get the CPU running today. Not any graphical capabilities, but like the CPU can successfully run that. And then all the cartridges. And then I would say that's all the Game Boy is. It's much more simpler than doing another type of emulators like any CPU that was made for an actual computer, not handhelds, because this is just a custom Z80. And so, yeah, I think we can actually get started looking at a few components of it. Like it says, it uses a custom Sharp LR35902. So if we search up Sharp LR35902, you can just see it's part of the Game Boy, and I don't want any of this. I don't want like any like copy and pasting code. I don't want to do any of that. I want to actually do it myself. So here we go. Here's a bit more less Wikipedia. So we have ourselves basically the board layout. We have the chip right here, the Game Pack Edge connector. We have the RAM, and we have a bunch of we have some audio. We have the input here. We have a bunch of pins for the peripheral power and peripherals, if I can speak. And so yeah, the Game Boy, which is the first row, runs at this, and it only has 4 colors, like I said. Later on, I could do color, which has a lot more color because it's made in 1998 when 3D was just, being like worked on, so they can get as much color as they want. So it actually kind of talks about both CPUs here and what each part comes from. So we have all the chip memory, like the stuff on the chip, like all the registers and all that is on this, and then all the instructions is with this. So then here's how they work. And then the hardware for the Game Boy Advance, which I really don't need. But anyways, any questions? We're excited. I don't need works cited. So this is just a little overview of the Game Boy. So I'm actually just going to get a Z80 Intel 8080 data sheet, because that's what we need to work on. And so as you can see, we have a little data sheet right here. We need to find the right page, wrong page. The instruction set is what we need, so we also need this instruction set. If we're not going to use that instruction set, we're going to use the Z80's instruction set with a little bit, more stuff. I can actually get the registers in the Wikipedia page, most CPUs. So we're going to try to get the CPU done, or at least implemented, and then instructions can be added easily to where I can do that just typing in what each instruction does. And so with this, we have what we need for the first CPU. So in our Java project, we can actually, let me get rid of all this Gradle. We don't need Gradle. So in here, we can just create a new package. We're just going to call this main. And this is where all the main program's going to be, and then in here we're going to have emulation, and then this can be where the CPU can hang out. So in here we need a few things. Like I said, we need the registers, so we have a couple registers. The weird thing about it is that they can actually be combined together. 3 of them can be combined together. The BC, the DA, and the HL can be combined together into bigger registers, 16-bit registers, because each register is 8-bit. Combine them together, you get 16-bit, which can go up to 65,000, 64K. And that's actually really good, which is pretty advanced for the time, especially since this came out in 1982. Oh, it came out in 1974. So even though the Game Boy came out with great packages and class names, I know I like to be organized. I mean, if you're not organized, then it's just going to be a big mess when you try to even like add anything else to it. So if you're trying to add audio or visual stuff, it's going to be super hard. So let's get started actually putting in this. So I'm actually going to make these private variables and then do some getters and setters just to clean things up a bit. So if we go into what we need a register or an accumulator, and that's just going to hold all the math. And I'm going to actually do what it actually is. Since it's an 8-bit number, I'm actually going to use byte, which is 8-bit number in Java. So 8-bit numbers can only go to 255, and this just makes it so it actually is an 8-bit number, and I don't use an int number, and that can cause errors later on. So it's going to be called a register A. Like I said, there's also these other 6 registers. There's also a flags register, but we'll be doing that until a little bit after we do these registers. These registers can combine together and give us a 16-bit number, which is very useful, but it's also very complicated to implement in here. Meaning I can actually make like a class in the CPU called register pair. So public register pair. So in here we can discuss I agree it would be so a register pair, this is where we're going to hold the register pair like the BC, DE, and HL, and then depending on which register it is, we can actually do this. So the first one I'd say is going to be, how should we name this? Because this is just going to be bc.register1 private byte register 1. We also need register 2. And then in here we can actually just say register 1 is equal to 0 and register 2 is also equal to 0. Okay, so why is there so much echo? It's because not in the room I'm currently recording, I'm actually away. And that's because it's the weekend, I'm away. My parents want to. And also, this is the worst room to actually record in, but it's the closest to the internet, and I wanted to actually live stream consistently. And also the mic sucks. So there's a lot of factors to why I have some terrible audio quality. If I brought my mic and it made it a little bit better, but I think it would have been a lot more echoey, because it can actually pick up a lot more echoes than the mic I have just on my laptop. If I really wanted to, I could go like in a closet. I'd rather breathe. So just something, can't really do much about it. Yeah, so anyways, let's continue on coding. So also welcome Michael Obvious. Great to see you at the stream. So yeah, I'm just going to be doing a few functions, probably public get register one, and it's going to be a byte, so return byte, return register one, and the same for register two, and it's just return register two, and then we need to actually say public, is it word? What's the 16-bit 16-bit number in Java? Short. It's called a short. Okay, so short. So public short get register. And so that's actually going to return like the entire 16-bit, like both of them combined together. So we need to return register one shifted 8 degrees or 8 bits. So it makes it a 16-bit number, and then also have register 2 ORed with that, and then we actually need to cast to short. I did add a cast to short. Okay, that's weird. I guess I have to put the in parentheses first. You would run out of oxygen in the closet with new. I know, so I'd rather breathe and not die in a closet. I don't even have like the room I record in is just really insulated, so it really can't. It makes it a lot. It's just a lot better for audio quality. Also, the mic makes it a bit better if I could ever find it. So, and add a cast to short. All right. So this is weird how I have to cast so many times. But I think that's right. And then we also need set. So I'm just going to copy this, and I'm going to say set. They all need to be void. Void. Because if you set, you don't really return anything. So set register 1. That's going to take in a byte new or value. And just say register 1. I have caps lock on. Register 1 is equal to value. And I'm just doing this just to make it easier on me. And then I have to do the same thing for register 2. Remove the second one. I can't remove this though. Like, if I remove it, it's going to throw an error. Well, it won't throw an error right now because I have to fix these first errors. So I set register 2 and then set register. I have to fix all these errors. Just say let. I can't say let, that's JavaScript. Short cool is equal to this. And it's going to throw an error that I have to cast to short. What I think the problem is that since this is a byte, I have to cast this to short, and then that makes this a short, and then I can OR it with this, and it makes the entire short. I'm probably going to test this before to make sure it actually works. I can't remove this one. Oh, I have insert on. See, I can't remove any of them. Oh, I can remove something. Dang. Well, thank you for that. I thought that was the second one. Yeah. I don't know if that's actually going to work, but hopefully it does. So short value, and then we need to set register 1 register 1 and 2 based off that. So register 1 is equal to value. We have to cast this to byte. I know we have to at least cast this one to byte. It's going to be value shifted to the right 8 times because we need to have the first half and then register 2 is going to be that, but only the first register 2 is going to be equal to the byte of value. I think that's going to work. And so there we go. So now that we have register A, we also probably need to actually initialize this. So CPU register A is equal to 0. And now that we have this little private class in here, we can say private register pair. I'm just going to call this BC. Yeah, and then registers, register BC, and I need two more. I need register DE, and then register HE or HL. And each one of them has their purposes. Register A is for math, register BC is for basically incrementing, and register HL is for the address. So very useful. And then I need to actually initialize these in here. So register BC is equal to new register pair. And then we can copy and paste this the same times, and then just say DE and HL. And that should be those general use registers done. And I can actually test this. So I'm going to make a main program just to test this to make sure that I'm not being completely stupid. I have to name like that. Public static void main string array of args, and now I can actually do something. So in here we need to have ourselves a CPUs, public CPU, import that. And what I'm going to have to actually do is in the emulation I'm going to make like a Gameboy class, and that just exports all this and actually makes them work together. And then in here we can just say Gameboy dot and then do all the other stuff besides actually running a Gameboy. So in here we have the public CPU, and so now we can do CPU dot register. Oop, code recommenders is not cool. So CPU dot register. Let's do BC, and then we're gonna set. If in your Discord server, you can put a bot to announce when you release a video like me. 6. I tried doing that with me E6. I've tried doing that, but it's not working. Like, I don't understand why it's not working. Yeah. I just did it myself when I posted the video, but then when I'm live streaming, I'm just like, yeah, it's whatever. I actually have to initialize this. CPU is equal to new CPU. Oh, these are private. I have to get getters. So source, generate getters and setters, select getters, and then for register A, select both. I forgot to do that. So we have get register A and set register A, and then for the register pair, we already have getters and setters for that. So CPU dot get register BC, and that sets it. So what's the problem here? I have to change it to static apparently. The type register pair is not visible. Do I actually have to? I can't make this a public class. See, I can't make it a public class. So I have to actually go in emulation, new. I was trying to be all good and all, like putting it all, we're all like organizing this to where, like using register pairs in here, but I can't do that because apparently I can't. Oh well. Oh wait, do this right there. All right, so now in here, I actually need to provide it I'm going to provide it with, let's do A. So, what's the problem here? Man, there's such a problem here. How is that? I have a solve for that. Oh, you do? Oh, nice. Can you tell me? Because I really want videos to be announced on my Discord. And also, this doesn't make sense because this is a byte. I don't have to. Do I have to keep casting to a byte? Make a getter for the class. I have like a get this. I just made a different class. I don't really want to. I don't want to cast a byte. I just want to. I mean, I can do this. Let byte, or not let byte, just byte number is equal to, and then I can just put a number. It's a bit more explicit, but it'll work. So, and then I want to do the same thing for register 2 on BC. So, and then on a system.out.print print line, and then CPU.get register BC .get register. So let's see what that does. 2,570. I don't know. I don't know if that works. I mean, I could probably .2 hex. .2